The word loo in England is toilet. Okay, I did not know that. There was a joke going on when I had a dinner. Okay, at McMaster, all the profs say water toilet. I'm like, what? Then when I drive home, I cannot stop laughing. Okay. So they asked me to prove it. I went away. Not too long later, I did this. Okay. So the stress measured is at what? Okay. So all I need to do now is to determine epsilon PL. If I can find the plastic strain, okay, then we have business, okay? So I put in values. A is 550 plus by B 650. Epsilon PL, the N is what? 0.23. Okay. So this will be 3,000 minus by 550 divided by 650 is equal to 3.769. Or I'll do the simple math. Or I'll write out the simple. I don't want to skip step. Okay. So 3,000. 3.769. Okay. So epsilon PL is equal to 3.769. Okay, so 1 divided by 0.23, okay, 3.769. Power of that value is equal to 320.133 or 32,013%. You see where the problem is now. This is what? Are we clear? This is physically what? Impossible. Now, when I did this contract, they did not pay me yet. They just want me to like, can you check our values? No money yet. Then some smart guy say that maybe there is what? Maybe there is what? Maybe there is martensite what? Formation. Okay. I went away. I looked for the mechanical properties of martensite. Still no money paid yet. Huh? So the A value is 900 times 10 to the power 6. When I saw this value, I start to panic. The V value for martensite is at 2,000. Now all these are for what? Martensite. And the N value is equal to 0.4. As I told you guys, I start to panic. Okay. So you have, again, the same formula, 3,000 times 10 to the power 6. Now this will be equal to 900 times 10 to the power 6 plus by 2,000 times 10 to the power 6 epsilon PL 0.4. Okay. So you have 3,000 times 10 to the power 6 minus by 900 times 10 to the power 6 divide by what? 2,000 times 10 to the power 6 epsilon PL power of 0.4. Okay. So this will be equal to 3,900 divided by 2,000 is 1.05. And this is equal to epsilon PL multiplied by 0.4. Epsilon PL is equal to 1.04 power by 1 divided by 0.4. Okay. So this is equal to 1 divided by 0.4, 1.04 power. So this is equal to 1.10 strain or 103 strain or 100.3%. Okay. Again, what? Especially for what? Yes. Oh yeah, 1.05. Got too excited. Thank you. 1 pint of alcohol. No, 1 pint of beer. Okay, not alcohol. You're right. It's not right. So this is 1.1. 1.130. Okay. You need to know what you're measuring. Okay. So it's also impossible to have mutton side. After this, then I got $28,000 from them to measure what? Residual stress. The company we use is known as American Stress Technology. Okay. And up to today, they bought the equipment from American Stress Technology. And now, up to today, I believe they are measuring residual stress with the same equipment. I was stupid. Why was I stupid? I should have bought the machine and sold it to them. Yes or no? Not thinking. Are we clear? Okay. Knowledge. Okay. Knowledge is the bliss. So this is all we are going to talk about. Residual stresses. Okay. That's all we're going to talk. Okay. The next part that we're going to do is going to be a very interesting topic. Okay. We are going to talk about manufacturing or manufacture of component with carbon fiber reinforced plastic. Okay. For this topic, I'll give you a good hint. You have one long question plus 5 multiple choice questions. Okay. The topic before this one, I'll give you a very good hint. You're going to have 5 multiple choice questions. So when you study, you can focus. Okay. Okay. The thing about carbon fiber, how many of you are dealing with carbon fiber? None. When I say carbon fiber, is carbon fiber that can withstand load. not those you put on your car to make it look beautiful. Okay. Again, companies like Multimatics have made a complete car body shell out of what? Carbon fiber. There's someone working for Multimatics here, right? Where are you? Hey? Yeah, for a co-op, right? And I remember this whole car body, not car, but the shell, I could lift it up, a real car body size. I could lift it up and I could walk with it. It's scary. Okay? There are crazy people down there. So this is why after I spoke to them, they say, hey, Eugene, well, how come manufacturing you don't teach anything about carbon fiber? Okay, so this is a request from industry. Okay, and it gets worse. So carbon fiber can only withstand, okay, stresses in tension and loaded and loading in the axial direction. It's only good in one direction. Okay. If it's in another direction, not very good at all. It's not good. So if you have one fiber, okay, the green line is the neutral axis. Okay, so this is our neutral axis. No, not neutral axis, sorry. Centroid axis. Have to be careful. Okay. And it's only good if the stresses are loaded this way. Okay, so this is our carbon fiber. Okay. Unfortunately, okay, carbon fiber cannot withstand shearing stresses. Okay, it's just not meant to withstand what? Shearing stress. Okay. So relative to the applied load, okay, relative to the applied load. So this is if this is our carbon fiber, right? And this is our applied load, P. We tend to call this 0 degrees. Okay. And then if we tilt it in a certain angle, okay, so I call this 45 degrees. The load is still relative, is in this direction. And then the last one, this is at 90 degrees. And the load still in this orientation P. Okay. So if you look at this, going towards the left, it has the highest what? Strength. And then if you go over here, this is the what? Lowest strength. Okay. So carbon fiber is very sensitive to how things are loaded. Okay. So in order